In this video, I will begin talking about the characteristics of circular functions, and I will begin with circular functions being periodic. So why is it that they are called periodic? I went to the dictionary. This one comes from Merriam Online Dictionary, and this is the meaning of something that is periodic. It is something that occurs or recurs at regular intervals. It occurs repeatedly from time to time. It consists of or contains a series of repeated stages, processes, or digits. A synonym for periodic is something that is cyclic, something that occurs in cycles. So again, cycles there has to do with circles. You don't have to go to math to know what it means when something is periodic. The girls among you experience this. You call it your monthly period. And your monthly period pertains to your menstruation. It is something that happens to you repeatedly at predictable, regular intervals. So on average, an adult woman experiences her menstruation every 28 days. So you would say that the period is 28 days. What is it about the circular functions that is periodic? Well, the graph. So when we lay down the graph of these functions, you can see right away the repeated patterns of the graph of your circular functions. So this one is the graph for y is equal to cosine of x. And so if we are to trace one cosine curve, let us begin with when x is equal to 0. So when x is equal to 0, cosine of 0 is 1. So let us trace one cosine curve. Okay, so that is one curve. That is another curve. And so if you want to produce the graph of the entire function y is equal to cosine of x, all you have to do is just to repeat, okay? Repeat and repeat the cosine curve. It's the same with your y is equal to sine of x. So this one is the graph of your function y is equal to sine of x. So again, let us trace one sine curve. So starting from this point, when x is 0, sine of 0 is 0. So let us trace one sine curve. That is one sine curve. And then it repeats the pattern. It repeats the pattern. The same must be said of your tangent function. Look at this. Let us define periodic functions. A function f is periodic if there is a positive real number c such that this is true, f of x plus c is equal to f of x. Or for our circular functions, this is true. Sine of x plus c is equal to sine of x, and cosine of x plus c is equal to cosine of x. The smallest number c is the period of the function y is equal to f of x. So why are sine and cosine functions periodic? Well, we have to go back to how are we evaluating the sine and cosine of an angle. So we have to bring back your unit circle. So if we shall trace an arc whose length is x, this arc has an endpoint. And the first coordinate of that point is what you call your cosine of x. And the second coordinate of that point is your sine of x. Well, guess what? If we shall make one more complete revolution, okay, so that is in fact equal to 2 pi, we are back to that same point. The arc is longer than x because this one is x plus 2 pi. That's x plus 2 pi. That is a longer arc, but it brings us to the same terminal point. So the cosine of that arc, which is a longer arc, is going to be cosine of x, and the sine is going to be sine of x. And so that is the reason why our circular functions is periodic. What is the period of this function? Y is equal to sine of x. Okay? So let's say, for example, this is our arc whose length is x. So sine of x is the second coordinate of that point. Starting from this point, I will make one complete revolution. And that one complete revolution is equal to 2 pi. And guess what? It returns me back, or I am back to the same terminal point of the arc whose length is x. So that is telling you something. The period of your function y is equal to sine of x, okay, or y is equal to cosine of x is 2 pi. That is the smallest number c, so that sine of x plus z is equal to sine of x. Okay, so let us verify that from the graph of our sine and cosine functions. So let us trace one complete sine curve. Okay, so starting from 0 to 2 pi. Okay, so that is one sine curve. But look at this. After 2 pi, you are going to trace the same curve in the interval 2 pi to 4 pi. It's like every 2 pi, look at this, from 0 to 2 pi, that's 2 pi. From 2 pi to 4 pi, that's another 2 pi, okay? The length of that interval is 2 pi. From 4 pi to 6 pi, again, the length of that interval is 2 pi. So every 2 pi, you are repeating the graph of your sine function. Y is equal to sine of x. So the same pattern is revealed by your cosine function. This one is the graph of your function y is equal to cosine of x. So for both of these functions, y is equal to sine of x and y is equal to cosine of x, the period is 2 pi.